The other great thing about these is you can make them so they're very, very easy or incredibly hard. You can make these things at any level of difficulty. So there's ways you can make it for you could probably do this for first graders if you have a 3x3 grid, because there are just so few possibilities. But you could have a 10x10. I mean, so, it's one I wrote. Everyone's welcome to have this if you have a Mac, because I'm incapable of programming a PC. But yeah, if you want a copy of the program, just you've got my email address on one of the forums. Just let me know and I can get you a copy of this thing. And it's not guaranteed, it's written by me. All right, yeah, comment.
I have a question about calculators. I don't know if you want to try to answer it. I don't have a lot of experience with KenKen, and for me, I'll do a 4x4, 5x5, or maybe a 6x6 with no calculator. But even 6x6 and up, it's like I have to have a calculator. Like, if I'm multiplying to get 288 or... I mean, maybe I'm just lazy. I'm just wondering how people feel about that, either in general or in working those bigger ones with kids. Clearly, we don't need a calculator here.
Yeah, if you think about it, it's not as horrible as you fear. Suppose that you have some clump of things, let's say on a 6x6, that multiplies to give 288. So basically, you think about it, what you need to do is factor it. How many factors of 2? But it can only have factors of 2, 3, and 5. So you can just keep trying to divide by 2, and get all the 2's out, and it's only 3 and 5. Even on a 10x10, you only have to check factors up to 7. Even if you had some numbers that multiplied to give, 42,000 something or other, that it's 2's, 3's, 5's, and 7's because there's no number larger than, well, there's no primes in there larger than 10. So, but it is that's a really good strategy, by the way. Suppose that we did have a group of cells, and the clue was it multiplies together to give 288, right? That's 12 squared. That's 144 times 2. That's how I remember it. And I can do 12. Do you see what I'm saying? And that's actually one of the nice things about these puzzles is you start learning factorization. You start learning how the bigger numbers are put together. I think I'll get to this a little later today, but it's possible to make these puzzles more interesting. Like, some puzzles don't even have the operations in. So all it'll do is say 10. And that would mean they either multiply together to give 10, or they add together to give 10. See? So there, it could then be 4, 4, 2, 3, 3, 4, or it could be 1, 5, 2, because if you multiply 1, 5, and 2, you get 10. So, but that would mean, what if you have two squares on a small puzzle like this, and it says 7 with no operation? It has to be addition, because 7 is 7 times 1. That's the only factorization. So and there's no 7 because it's 4 by 4, and so it's got to be addition. So you can make these observations simply by learning how to factor things in your head in some sense too. You got a 13 in there, boy, it's likely to be addition.